All right, so in this video, we're going to go through the more challenging trig application problems that we were looking at in class. I would strongly recommend you do as many of these on your own first before referring to this video. And at any point during the video, pause it if you feel like you could finish the problem without me. All right, so we'll go through this first one here. They are telling you that in some right triangle, so we could draw a right triangle, ABC. We actually don't know where B and C are, it doesn't really matter. They are telling you that tangent of A is 3/4, and they want you to find sine and cosine. And so I've given you a hint here, which is to make a right triangle where that's going to be true. So tangent, right? We know so, ka, toa. All right, well, tangent would be opposite over adjacent. So if angle A is right here, get the opposite. Okay, so if it's going to be 3/4, that means opposite would be 3, and adjacent would be 4. Right, but now they want me to find sine of A. Okay, well, sine would be opposite over hypotenuse. I don't know the hypotenuse, but I could find it because it's a right triangle. So I know that 3 squared plus 4 squared equals, we'll just call this like x. Okay, and that's a 3, 4, 5 right triangle if you haven't realized that already. And so you'd get 5. And so sine of A is simply opposite over hypotenuse, 3/5. And cosine of A is adjacent over hypotenuse. And that's your answer. So you actually don't even need a calculator for this one. Second problem. These go in order of the worksheet. So here we've got a rectangle, and they're telling us it's 10 by 5. So let's start by drawing that. 10 by 5. Of course, we know all the sides are going to be congruent. Okay. Determine the measures of the angles of the point where the diagonals intersect. So let's draw the diagonals. Okay, so in other words, we're looking for these angles. And really, we just need to find one of them, because as soon as we find one, we know all four. Okay, so now we just need to think, okay, so how can I apply trigonometry? So in all of these questions, you're using sine, cosine, or tangent somehow. Well, we can only use sine, cosine, and tangent if we have a right triangle. Oh, but this is a rectangle. And so I know rectangles have right angles at all the corners. So, that's a right angle. That would make this a right triangle. So let's see, how could that help me? Let's pull this down here. Now, I would like to know this angle here. So we look at that bottom triangle and we realize, hey, that's an isosceles triangle right here. So if I found this angle, well, then I would know this angle, and that would let me solve for that angle. But let's find this angle down here. Okay, let's call that x. Oh, okay, now I could just use tangent. Right, tan of x equals 5/10. So let's type that in our calculator. Right, let's do tan inverse of 5/10, or you could reduce that to a half, so just give me a minute to figure out what that is. 0.5. So I get 26, about 26.565 if we round off to 3 places. Okay, well, that would be that angle. And you would know this other angle would be the same. And so we could double that, right? We could multiply that by 2. So let me punch that in my calculator real quick. And so I get 53.13, and then we could take that away from 180 to get the final answer. So I get about 126. So this angle right here ends up being about 126 we'll round that to 9 degrees. Okay, obviously, as you do this, you may get slightly different answers depending on the way you round things or go about things, and once we know that's 126, then we can also find this angle because we know that those add to 180. All right, the third question. The lengths of side AB and BC. Okay, so they're giving us a triangle, some triangle ABC, and it's scalene, so we know all the sides are different. Now, I don't know what this triangle looks like, so I'm just going to draw any triangle and start labeling it. And maybe I have to erase and start over, but like you got to get somewhere, right? So put something on your page and then just start labeling. So 12 centimeters goes with respectively, so AB, okay, and BC is 8. Okay, and they also tell me C is 59 degrees, so let's put that in here. And they want you to find the length of side AC, so we would like to find this. And we're going to see that we can't do that in one step, unfortunately. Okay, so we stare at this for a while. How am I going to use sine and cosine or tangent? I don't have a right triangle anywhere. Okay, so this is where you need to realize, like, you can make one. You can introduce the right triangle into this thing. So, like, I'd like to find this side. Well, what if I drop this line right here? Right, so somehow I got to use this 59-degree angle. Okay, well, if I do that, I get a right triangle now. I could solve that. Right, if I focus on this triangle here, I have 8 and 59. Oh, well, so I could solve for this. Now, that's not the full answer, but I could set up, let's see, that would be cosine of 59. Let's just call that like x or something. Would be adjacent over hypotenuse, and I could solve. So x would be approximately, punching that in my calculator, 8 cosine of 59, I get about 4.12. 0 if you round off. Okay, well, I don't know the whole thing, but I do know part of this side. So now what I could do is I could work my way over. Right? I could also solve for this side of the triangle, which in our picture would be the height. And then once I know this, I could then use that to solve for this. And then I could add those together. Okay, so I'll quickly speed through the math for that, but if you want to try that at this point, you know, pause the video and please do. Now, I would use Pythagorean theorem here, right? Now that I know that this is 4.12, I would just say, let's call this like y. 4.12 squared plus y squared equals 8 squared. I wouldn't even use trigonometry anymore at this point. So let's just get what that's going to be. So 64 minus 1.12 squared. And take the square root of that. Okay, so I get that y is about 8, or 6 rather, 0.856. Right, and now once I know this, let's just fill that in, it's like 6.8. Now I could solve for this. Right, and again, you could use, well, actually trig would be difficult because you don't have an angle over here, but you could just use Pythagorean theorem. So you could say 6.856 squared plus, let's just call this like, you know, w or something, equals 12 squared, right? And go ahead and get that. So 12, so 144 minus 6.586 squared, take the square root, and I get 9.849. Okay, and so the final answer is going to be this plus this. And so that final length is what, like about 13? Yeah, so 9 plus 1.12. So I get about 13.96, approximately. Okay, so that required a couple of steps to get to the answer, but you can see what we're doing. We're breaking the triangle into right triangles so that we can use trigonometry, we can use Pythagorean theorem, we can use the things we know. Okay, so when you're taking the test, that's what you want to be looking for. Like, if there isn't a right triangle, could I make one? All right, from the top of a 200-meter high building. All right, so let's try a 200-meter high building. The angle of depression to the bottom of a second building. Okay, so there must be some building across the street. And I know it's going to be taller, so I'll draw that. Okay, so from here, right, how do we draw an angle of depression? We go from the horizontal. The angle of depression is 20 degrees. from the same point, the angle of elevation is 10 degrees. Obviously, I'm not drawing this to scale very well. Calculate the height of the second building, because we are looking for this. But again, it's going to be hard to find it directly. So what we can do instead is find it in sort of two pieces. Okay, what we have done here is we have created right triangles. And so we could solve for this. Or sorry, actually, we already know this. Sorry. We know this is 200. Right, so we really just need to solve for this. But here's the problem. We don't know anything about this triangle yet, besides the fact that there's a 10-degree angle. So what we can do is we could solve for this side and then use that to solve for this side. Again, you may want to try that yourself at this point, but I will go ahead and do that. So I'm going to call this x and I'll call this y. I know tan of 20 is going to equal 200 over x, right? Opposite over adjacent. And so punching that in my calculator, I get about 549.495. Okay, so that's the distance from here to here. And now we can put that in our diagram. Okay. And now I can set up another trig ratio. Right now I can use the 10. So tan of 10 degrees equals y over for, that length there, 459 or 549. So we multiply that by tangent of 10, and we get about 96. 96.891. Okay, so now we've solved for this plus the 200 we knew from before, right, to obtain our final answer in meters. This, I think, is the hardest question. Okay, Carla, it's the hardest to picture. It's the hardest to set it up, at least for me anyway. So we're in this hot air balloon and we are traveling straight up directly over a point P on the ground. So just in other words, here's point P and the balloon is going up from there. It's going to be easier to draw this in two parts. So she spots a parked car on the ground at an angle of depression of 30. So here's the car. Here's, the hot air balloon in the air. Now, notice we don't know how high up the balloon is. They don't tell us that. But we end up with this. Angle of depression of 30. Okay, now remember, with angles of depression, because these are parallel lines, these would be the same angle. So you can also think of it being down here. All right, so now she's going to go up 50 meters. So let's draw another triangle here, higher than the other one. Okay, and now, right, the angle of depression is 35 degrees. Okay, so what changed? So the distance from the car to point P is what we're looking for. And here's the car, here's point P. Let's call that like x. Now, x didn't change, right? The balloon didn't move left or right. It only moved up and down. So what changed is this other side of the triangle. So we don't know what it is. So let's call it like h for height. And we know because, right, they tell us the balloon rose 50 meters. So this would be h plus 50. And these are right angles. And so I could set up two trig ratios. I could say tan of 30 equals h over x. And I could say tan of 35 would equal h plus 50 over x. What I have is a system of equations with two variables. And you've worked with those a lot, right? Since Algebra 1, you know you can substitute when you have a system of equations. So let's do that. Why don't we get x by itself? Or let's get h by itself. All right, so if I multiply both sides by x here, I get x times tan 30. Tan 30 is just a decimal, right? So let's just type that in our calculator. So tan of 30 is about 0.577. Okay, now we can plug that in. Now that we know h, we can plug that into the other equation. And I'm just going to figure out what tan of 35 is. So tan 35 is about it's almost 7 exactly. So I'll just round to that. No, sorry, not x. And then I'm replacing with this, right? So I'm taking this equation and I'm substituting for h. And now I have one variable. And so I can multiply both sides by x to clear the fraction. And so I would get 0.7x equals 0.577x plus 50. And that's an easy equation to solve, right? With my calculator, it's not too bad. So I'm going to go ahead and do 0.7 minus 0.577 and divide. So 50 divided by that. Okay, if you go through and solve that equation, you will get x is approximately 406.504. The unit is meters. And at this point, you're done because you were looking for the distance from the car to point P. But you could, if you needed to plug, like if you wanted to figure out the height of the balloon, you could plug it back in and find it. But in this case, they're not asking for that. A couple more questions. The shadow of a building increases by 10 meters when the angle of elevation decreases from 70 to 60. Okay, so when you look at a building, like the sun's rays, the angle of elevation looking at the sun is also going to be the angle that the shadow, like the end of the shadow will make if you look to the top of the building. So that's kind of the realization you need to have for this one. Okay, so let's just draw a building. And we do not know the height of the building. Okay, but we do know that when the angle of elevation goes from 70 to 60, the shadow is going to get 10 feet longer. Okay, so again, kind of like last time, the distance from the car to point P didn't change. So in this problem, the height of the building didn't change. So let's call that, again, like h for height. What did change is the shadow. And so like in the original problem, let's call that, again, let's just like say x. And so when we go to this triangle now, it's simply going to be x plus 10. The way you're going to do this problem is very similar to the way that you did this problem. So you may want to pause the video now, try to set up a system of equations and solve this yourself. All right, but I will go through it now. So I will say tan of 70 equals h over x. I will say tan of 60 equals h over x plus 10. And let's see, I will get x or h by itself, so I'm going to multiply both sides by x. And I will just figure out what tan of 70 is right now. So tan of 70 is about 2.747. Okay, now I will substitute into the other equation. And again, I'll just figure out what tan of 60 is right now just to get that out of the way. So 1.732. It's actually the square root of 3. You'll learn that in pre-calc. And I end up here. So now I want to, let's see, get x alone. So I'll clear the fraction. Right, I'll multiply by x plus 10. But if I do it here, I got to do it here. And distribute, right? So I get 1.732x plus 17.32 equals 2.747x. And now I have an equation that I can solve with my calculator. So I will go ahead and do that. That minus that. And divide 17.32 divided by that number. I get x is approximately about 17.06. But I wasn't interested in x, right? So x is the length of the shadow. I want to find the height of the building. So now I just need to go and plug that back in. So this is good, but this is just not the final answer. Okay, so now I can go back, to this original equation I could use, or I could just use this, right? I know h equals 2.7 times this thing. Okay, and so h is about 2.747 times 17.064. I get about 46.875 if I round off feet, or meters, excuse me, meters. All right, so hopefully you see like how these problems, the hot air balloon and this problem are similar in how they're set up. And the last question. Now this one's very different than all the others. This is getting you to use trigonometry and applying it back to something we did in Unit 3, which was finding the area of regular polygons. And you had that formula, area equals 1/2 apothem times perimeter. 1/2 AP. Now they are telling you the side length of the shape, and there are 10 sides, so right away you know the perimeter is 150. Right, 10 times 15, but you do not know the apothem of this shape. So first we need to remember what an apothem is. Okay, if you have some polygon, this is like an octagon, the apothem is the distance from the center to an edge at a right angle. There's the key, right? Anytime we see a right angle, we should immediately be thinking, maybe I could use Pythagorean theorem, maybe I could use trigonometry, right? Something here, I know I can do something with right triangles. In this case, we're going to use trigonometry. So let's see, if I drew a right triangle like this, that would be helpful. But I don't know any of the angles of this thing besides the 90. So could I figure out this angle? Well, I know it would cut the angle in half, right? Because if I drew all of these triangles, there'd be sort of a symmetry and everything would be cutting in half. You go around and do it if you don't believe me. Well, so could I figure out each angle of this thing? Well, yeah, that's a whole formula we talked about in Unit 3, right? This will find the individual angles of any regular polygon. So let's do that. 10 minus 2 times 180 divided by 10. And so you punch that in, 8 times 180, and you end up getting 144. But then you're going to cut that in half. Right, so you're splitting that angle in half, so you get 72 degrees. All right, so now let's look at that right triangle. So this is 72. The apothem is this distance here, so I'll call that A. I need to know at least one side of this thing, and that is where this is helpful again. I know the side length is 15. But again, when I draw this line, I cut that in half. Okay, so this is 7.5. Oh, well, now I could just use tangent. So tan of 72 would equal the apothem divided by 7.5. And I can punch that in my calculator. Tan of 72, and I end up with 23.083. I win. I'm done. I just need to plug that into my formula now. All right, so I knew the perimeter. Now I know the apothem. So 1/2 times 23.083 times the perimeter, and we punch that in our calculator, and we get 150 times 0.5, 173.225. And the unit is, if this is in inches, because we are talking about area, this would be inches squared. I could change this to a 20-sided figure or a 24-sided figure. It wouldn't matter. You would do the same process. The only thing that would change is the angle that you would get, but you would do the same thing. I hope this helped. We will go over these in class, of course, and if you ever have a question, feel free to email me. Let me know what I can do. Otherwise, have a great day.